Hello. In this video, we'll look at a very simple fuzzer called Sfuzz. Now, as many of us know, fuzzers have now become very important as far as testing protocol level code is concerned. The simple reason being that generally when programmers write their code, it is for all the various different use cases which they anticipate will happen in a given network. However, a fuzzer will actually generate an all possible random input into the program for which various checks might not have been done in code, and thus a lot of bugs can be uncovered. So there are a lot of fuzzers available out there, Spike being one of the more powerful and robust ones. But generally for small tasks, Spike is an overkill. So in this video, we will explore how one can use Sfuzz for very simple fuzzing tasks. Once you've installed Sfuzz, go ahead and look at the README file. This is where the simple scripting language which Sfuzz uses has been described. So I'll not get into the specifics of this. Please have a look. It's very simple to follow. In this demo, I'll show you two cases using Sfuzz where we can conduct a fuzzing attack. So in the very first one, we'll use one of the pre-shipped scripts which Sfuzz uses. So as we can see, the input to Sfuzz needs to be a configuration file, and then depending on if we want to transport the fuzzed payload over TCP, UDP or just over STD out, we need to select that option. So let's actually look at the sample script which already comes with Sfuzz. So in this first demonstration, we look at a very simple HTTP fuzzing attack. So this is where the configuration to Sfuzz has been mentioned for this fuzzing attack. Now once again, look at the README file to understand exactly what all this means, but I'll try to very quickly describe some of these things which have been written. So sequence, basically what sequence means is that the letters you're mentioning here after that, say %n, you basically tell the fuzzer that I want to go ahead and repeat this over and over again as a sequence. And the number of times this will be repeated is dictated by max sequence len, which in this case is 10,024. So what would happen is in this case, %n would be repeated 10,024 times. In this case, %f would be repeated. The second thing which is used by Sfuzz is called literals. Literals are strings which are used as is. So for example, when you say literal is equal to a really bad string, this string is going to be substituted into the first payload as is. Then you can include other files which contain a similar kind of a configuration script. Req-wait is nothing but request wait, which is, let's say if you want to go ahead and send this fuzzing payload over a network, then what is the minimum delay between various TCP or UDP based requests? Then once the configuration is done, we end it using end CFG, which is end config. Then after that, we start writing the test cases. So whatever we write after that is transported as is into the payload. What we need to make sure is that wherever we want the first payload to be included, we need to mention the fuzz keyword in capitals there. So in the first case, the root page will be fetched. The double dashes means end of the test case, which is test case 1. The second case, get/fuzz, which is basically the first payload which will be created, will actually be substituted here, and the HTTP request will go ahead. And there are many such test cases available. So let's quickly fire this demo up. So as we know, let's go ahead and send this HTTP fuzz payload to, let's say, Google servers. So we say, okay, it has to be over TCP. Also output whatever you're sending onto the STD out. Then take the configuration file, which in this case is sfuzz sample HTTP. And then we need to mention the remote host and port. So in this case, let's say google.com, and in this case, port number is 80. Right, let's go ahead and fire this. Now, as we notice, various fuzzing attempts are now going on, and whatever is being sent is actually being displayed on STD out. So this way, it is actually possible to go ahead and test various different programs using this very simple fuzzer. So now in the second part of the demonstration, let me show you how to uncover a buffer overflow vulnerability using Sfuzz. So before we go into that, I'll open up a very simple program which was available in one of the previous videos which I had made, which is the TCP echo server video. So this is the TCP echo server code, and it's a very simple piece of code, and as one knows, an echo server just sends back the string which we send to it. So what I've done is I've made a couple of changes to make this code vulnerable to a buffer overflow attack. So what I do is, as soon as the data is received from the network, from the TCP socket, I go ahead and copy that data in a function called copy_data. Now in copy_data, I have a vulnerable buffer called vulnerable_buffer, which is of size 100 bytes. And then a memcopy function, which is just going to copy the buffer into the vulnerable_buffer. However, there is no check to ensure that buffer_length is not greater than 100 is not greater than 100 bytes. So because of this, there is a buffer overflow possibility here. So what we'll do is, let's quickly go ahead and compile this code. And then let's run this vulnerable server and bind it to port 10,000. I think it's already in use. Let's bind it to port 10,001. Now let's go back to Sfuzz and write a very simple script which will send these fuzzing payloads to vulnerable_server. So as we saw, basically what we need is a sequence of a large number of bytes which we can actually send over to the vulnerable server. So let's use the sequence keyword, and let's say capital A is going to be the character which we want to send across. Now let's mention the sequence length. So for the time being, let's just mention it as 50 bytes, right? And the next thing we need to do is we'll just end this configuration and then go ahead and write the test case, which would be just send the first payload, end the test case, and then here we are. So we've created this very simple Sfuzz configuration file. So now let's use Sfuzz. Say we want to transport everything over TCP, and then in this case the remote host is nothing but the local host, and the port, as we mentioned right now, is 10,001. Now let's go ahead and, okay, the server is running. Let's send the payload across. Okay, we forgot a configuration file. The -f option, and then we have 1.cfg. So the vulnerable server is running, and if you notice, what happened was that this string of all A's 50 times was actually sent, right? and the vulnerable. So if we now go back to the server terminal, what we notice is that the client sent the 50 bytes all A's and the server received it and it has displayed the message on the console. So now as we send more and more messages, the server simply displays it and everything is working fine. So now let's go ahead and trigger the buffer overflow. So let's open up the warn.config and make the sequence length 500 bytes. Let's go back. Server is running properly now, but let's send the payload. And if you notice now, we have a segmentation fault. This happened because of the buffer overflow, which might have rewritten the EIP. So how do we go about and now figuring out whether that really happened or was there some other cause? The way to do it is actually fire up GDB and run the vulnerable server through it. So let's go ahead and run the vulnerable server. Address already in use. Let's give it 2002. The reason why that happened is because the previous server, when it was attached to 10,001 port, it just died and the socket is still kind of in lingering state. So now the vulnerable server is started on port number 10,002. Let's send across the payload. And now we notice segmentation fault has happened and the EIP is nothing but 41, 41, 41, 41. That is actually nothing but the value of A, capital ASCII A in hex. So let's actually go ahead and confirm this by saying info registers. And if we notice right now, EIP, EDP, ESI, EBP, everything has been overwritten. So this is actually the first step to beginning with a remote buffer overflow attack, where you successfully go ahead and overflow the buffer, and you know that now you can control the EIP, right? How to go about now developing an exploit for this is going to be probably a separate tutorial in itself, which I'll probably take up later. But the point I wanted to make here is, so this is how using fuzzers, it is possible to generate random inputs, send them to programs which might not expect them. The programs will crash. There might be a segmentation fault. There could be something else weird happening. And using that, a security researcher could probably develop an exploit to either go ahead and create a remote root, kind of a shell exploit, or a DOS exploit, depending on the kind of vulnerability. So well, that's all for this demo. Please download Sfuzz and try out a couple of such fuzzing experiments, and hope you have fun. That's all. Thank you.